Chapter 7.1 and 7.2 is all about enolate chemistry. Pretty simple. So, enol, it should immediately tell you that you have an alkene and an alcohol. And so, what's really important about this molecule is that it's extremely reactive and it has two forms. So, we call it a keto form is when you have the ketone, and the enol form is when you have the alcohol, right? Pretty straightforward. Your keto form is more favored due to stability, and enols are a very crucial part of especially biochemistry and biochemical reaction. So we're first going to go over a big thing that we call the alpha carbon. So what's so special? First, what is the alpha carbon? An alpha carbon is one carbon away from a ketone, from your carbonyl, sorry. So it could be aldehyde or ketone. So that means that yes, this is also here. This is also an alpha carbon. Now, what makes these so important is that they're extremely reactive with a pKa of 20 for this hydrogen. So, um, so it's extremely acidic, and then this here is going to take. Sorry, this is your base. So this is your acid. So HCl is going to act like your acid and deprotonate to get this guy, this structure here. So you're going to get a negative charge here. And then we all know that, let me go over charges. So this here is slightly negative, and then we know that this here is slightly positive, right? As if we drew our resonance structure, it would quite literally look like that, like what we just drew. Okay. So that's how you get to your first step of your enol, and then obviously you just pronate it, and now you have your full enol. I wouldn't be obsessed with knowing the formation, but this is like the proof, right? Like what makes an enol an enol? Like this is exactly the formation of it. It's really I showed you in individual steps, but we call it tautomerization, and usually it's done all in one step. So a lot of times you're gonna see it's gonna be like taut, and it's gonna be everything done in one step. So we have this hydrogen, it's gonna be picked up here. This is gonna fall here, and this is gonna fall here. And we call this tautomerization. So you end up with this. Okay, but I just showed you that all in individual steps, just so you made sure to know what's going on. Um, so yeah, pretty important stuff. Definitely one of the more important things. So you can get two different types of enolates, so we're going to go over that really quickly. So thermodynamic enolates and kinetic enolates. So thermodynamic, more stable. It's more stable due to it being connected to more carbons. So when we're talking about that, we look at only the alkenes, okay, and we see how many carbons it's connected to. So this one is connected to one here and one here, right? But then this one is only connected, sorry, one here, one there, then one there. This one's only connected to here, and sorry, it's only connected to here actually. Okay, so this alkene is more stable. So, but this only forms when you're a higher temperature and the reaction takes longer, but it is more stable. But you don't get as much of it. If we're talking about arrows, you probably are looking something like this. Okay, you're getting a lot more kinetic product than thermodynamic product. Thermodynamic product forms faster, and it's done at lower temperatures. So there's also one more thing. You'll see this more actually later in the video, so I'm not going to go over in too much detail. But your enamines can also turn into your amines, which you'll see very soon. What that means, actually, very soon. And and it works the same way as tautomerization. So you could also have tautomerization with your amines and enamines. So next video, we're just gonna go over the auto reaction, and then chapter after we're done that, we're gonna go over chapter 8, which is about carbonic acid. So see you there.